For thousands of years, humanity has looked toward the night sky and asked a simple but profound question: are we alone? Ancient civilizations saw the stars as gods, spirits, or celestial landmarks guiding their journeys across oceans and deserts. Later, philosophers wondered whether other worlds might exist beyond Earth. With the invention of telescopes, our understanding of the cosmos began to expand dramatically. We learned that Earth was not the center of the universe, that our Sun was only one star among billions, and that our galaxy was just one among countless others spread across the vastness of space. Yet despite all these discoveries, one mystery remained unanswered. If planets orbit other stars, could some of them resemble our own world? Today, humanity is closer than ever to answering that question. At the center of this new era of exploration stands the James Webb Space Telescope, one of the most advanced scientific instruments ever created. Built through decades of international collaboration, Webb represents a technological achievement unlike anything that came before it. Unlike traditional telescopes that primarily observe visible light, Webb specializes in infrared astronomy. This allows it to peer through clouds of dust, observe the earliest galaxies in cosmic history, and study the atmospheres of planets orbiting distant stars. Its mission extends far beyond taking beautiful pictures. The telescope was designed to investigate some of the most fundamental questions in science. How did the first galaxies form? How do stars and planetary systems evolve? And perhaps most intriguingly, could there be other habitable worlds scattered throughout the Milky Way? Among the thousands of known exoplanets, one world continues to attract extraordinary scientific interest. That world is Proxima b. Discovered in 2016, Proxima b orbits Proxima Centauri, the closest known star to our solar system. Located just over 4 light-years away, it resides in our cosmic neighborhood. In astronomical terms, that distance is remarkably close. To appreciate this scale, consider that light, the fastest thing in the universe, takes more than 4 years to travel from Proxima Centauri to Earth. Even our fastest spacecraft would require tens of thousands of years to make the journey. Yet despite this immense distance, Proxima b has become one of the most studied exoplanets ever discovered. The reason is simple. Unlike many exoplanets that are enormous gas giants, Proxima b appears to be a rocky world. Estimates suggest it possesses a mass slightly greater than Earth's, placing it in a category often referred to as a super-Earth. More importantly, it orbits within its star's habitable zone. Often called the Goldilocks zone, this region is neither too hot nor too cold. Under the right conditions, liquid water could potentially exist on a planet's surface. Water is one of the key ingredients for life as we know it. Where liquid water exists, scientists believe the possibility of biological activity becomes far more plausible. For this reason, the discovery of Proxima b immediately transformed it into a priority target for astronomers around the world. However, finding a planet is only the first step. Understanding what that planet is actually like presents a much greater challenge. Imagine trying to photograph a firefly flying next to a powerful lighthouse from thousands of kilometers away. The brightness of the lighthouse would completely overwhelm the faint glow of the insect. Astronomers face a similar problem when studying exoplanets. Stars produce enormous amounts of light, while planets merely reflect a tiny fraction of it. Detecting a small rocky world orbiting close to its star is therefore incredibly difficult. For many years, scientists could only study exoplanets indirectly. They observed subtle wobbles in stars caused by gravitational interactions with orbiting planets. They measured tiny decreases in brightness when planets crossed in front of their stars. These techniques allowed astronomers to estimate planetary sizes, masses, and orbital periods. But they provided limited information about planetary environments. Researchers could confirm that a planet existed without knowing whether it possessed oceans, clouds, mountains, atmospheres, or any conditions suitable for life. The arrival of Webb changed that. Using its powerful infrared instruments, the telescope can analyze the faint signatures hidden within starlight. When light passes through a planet's atmosphere, certain wavelengths are absorbed by specific molecules. These absorption patterns act like chemical fingerprints. By examining them carefully, scientists can determine which gases may be present. Water vapor, methane, carbon dioxide, oxygen, ozone, and other compounds each leave unique signatures. This technique, known as spectroscopy, has revolutionized exoplanet science. For the first time in human history, we are beginning to study the atmospheres of distant worlds in remarkable detail. Although Proxima b remains extremely difficult to observe directly, every new observation helps researchers build a clearer picture of what conditions there might be like. The planet's host star introduces both opportunities and challenges. Proxima Centauri belongs to a category known as red dwarfs. These stars are smaller and cooler than our Sun, making them the most common type of star in the Milky Way. In fact, approximately 70% of the stars in our galaxy are red dwarfs. This fact alone has enormous implications. If rocky planets around red dwarfs can maintain stable environments, then potentially habitable worlds may be far more common than previously believed. Yet red dwarfs are also known for violent stellar activity. Many produce powerful flares capable of releasing enormous bursts of radiation. Such events can dramatically affect nearby planets. Without sufficient protection, a planet's atmosphere could gradually erode over time. Surface conditions might become hostile to life. Radiation levels could rise to dangerous extremes. This is why scientists are particularly interested in determining whether Proxima b possesses a magnetic field. Earth's magnetic field acts as a protective shield against harmful solar radiation. Without it, our atmosphere would be far more vulnerable. If Proxima b has a similar defense mechanism, its prospects for long-term habitability improve significantly. Researchers are now developing increasingly sophisticated climate models to explore these possibilities. Using supercomputers, scientists simulate atmospheric circulation, cloud formation, ocean behavior, temperature distribution, and countless other variables. Some models suggest that even planets orbiting active red dwarfs could maintain habitable regions under the right circumstances. Others indicate more challenging environments. The truth may lie somewhere in between. Every new observation helps narrow the possibilities. Meanwhile, technological advances continue to accelerate. Artificial intelligence now plays a major role in astronomical research. Modern observatories generate extraordinary amounts of information, far more than humans can analyze manually. Machine learning systems help identify patterns, remove observational noise, classify celestial objects, and uncover subtle relationships hidden within massive datasets. The partnership between human researchers and advanced computational tools is transforming astronomy. What once required years of analysis can now be accomplished in a fraction of the time. This allows scientists to focus on interpretation, hypothesis testing, and discovery. The search for life beyond Earth has therefore entered a new phase. For much of human history, discussions about alien worlds were largely philosophical. Today they are scientific. Instead of asking whether planets exist around other stars, we ask what their atmospheres contain. Instead of wondering whether habitable worlds are possible, we investigate specific environments and measure their properties. The questions have become more precise because our tools have become more powerful. And perhaps the most exciting aspect of all is that we are only at the beginning. Future observatories are already being planned. Next-generation space telescopes may possess the capability to directly image Earth-sized planets around nearby stars. They could search for biosignatures, chemical combinations potentially associated with biological activity. One day, scientists may identify convincing evidence that life exists elsewhere in the galaxy. Such a discovery would rank among the most important events in human history. It would reshape our understanding of biology, evolution, philosophy, and our place in the cosmos. Even if no evidence of life is found, the search itself remains profoundly valuable. Every world we study teaches us something new about how planets form, evolve, and interact with their stars. Each discovery expands our understanding of what is possible. Perhaps most importantly, these investigations remind us how extraordinary our own planet truly is. From billions of kilometers away, Earth would appear as a tiny pale dot orbiting an ordinary star. Yet on that small world emerged oceans, ecosystems, civilizations, art, science, and curiosity itself. The fact that we can now examine distant planets and ask whether similar stories might unfold elsewhere is one of humanity's greatest achievements. As the James Webb Space Telescope continues its mission, it will undoubtedly reveal new surprises. New planets. New atmospheres. New mysteries. And perhaps, someday, evidence that life has found a way to emerge beyond Earth. Until then, the search continues. Every observation, every spectrum, and every discovery brings us one step closer to understanding our place in the universe. The stars that once seemed unreachable are becoming destinations of scientific inquiry. The worlds that once existed only in imagination are becoming objects of study. And with each passing year, humanity moves closer to answering one of the oldest questions ever asked: are we alone? The universe has not yet given us a definitive answer. But for the first time in history, we possess the tools capable of finding one.